Good morning, Year 6. It's Wednesday the 13th of May 2020. Another video. We're halfway through the week. Video focusing on an algebra recap, part of your My Maths for the next couple of days, and sequences. Sequences is something which you will probably find fairly straightforward, but not necessarily something we've particularly focused on in class. So that's what our next My Maths session along with the algebra will be. Some shout outs though, all of these children here that you can see, so Paulina, Michael, Norodin, Emily, Ethan, Robbie, Jensen, Reese, India, all getting 100% on their negative number recap. Lauren, Bella, Will 75, still an amazing score. Connor 100. All of you, this was as of yesterday, so some of you may have been on since then and done it, but really good scores. I'm impressed with those because it's been a little while since we've done negative numbers, but some really good scores. And then again on the worksheet with the revision of sort of key topics, I think it was fractions, decimals, percentages, ratios in there, angles. You can see that some really good scores again, so really pleased. Pauline, Michael, Norodin, Ethan Bebbington, I think so far the top score. This was as of yesterday. Yeah, well done, Bebs. Robbie, Reese, India, Bella, Kian, Connor, some excellent scores there, so really well done, and I look forward to looking at the other ones that come in as well. So sequences, there are two types of sequences that you can have and that you will come across in your maths education. Not that you need to know and be able to identify the two types of sequences now, but as you are able mathematicians, it's good to know. So you get arithmetic sequences and geometric sequences. Arithmetic are the ones we will be focusing on and you will come across at the moment. Geometric possibly not until certainly top end GCSE, maybe year 10, year 11 and A-level maths. Arithmetic sequences are when you add or subtract the same number each time. Okay, so, you know, we're adding 3, adding 5, etc. Fairly straightforward. Whereas geometric are where you multiply by the same number each time. So you may multiply by 0.25 or a quarter. You may multiply, you know, in which case the sequence is going to get smaller. You may multiply by 1 3/4 each time. Okay, you may multiply by 0.9 each time. Okay, so they're the two types of sequences you will come across. Arithmetic, geometric. There is one more, but that one gets particularly complicated. Okay, so we will just be focusing on these arithmetic sequences. Now, I'm not going to insult your intelligence and go through all of these questions because there are quite a few on the My Maths, but we'll just quickly take a look at this one. You know, to work out if a number or what the sequence is going up by is just to find two terms that come next to each other and then to find the difference. So clearly we know this sequence is going up in 5s. Okay, we are adding 5 each time. So the next number then would be 26, wouldn't it? That's straightforward. Now there's some algebra in this to work out if 56 would be in that sequence. Okay, by the way, this is term number 1, that's term number 2, that's term 3, term 4, term 5. So term 6 would be the next one, which would be 26. Term 7 would be 31. Okay, that's what we call inner sequences. They're called terms. So just to work out, would 56 be in this sequence? Well, we know that we are constantly increasing by 5. So it's 5 lots of the number. Okay, we're increasing by. And then, well, because we're increasing 5, we're doing our 5 times table. So underneath, I'm going to do my 5 times table. 5, 10, 15, 20, 25. That's my normal 5 times table in blue. Well, how do I get from my normal 5 times table, with the first term, which is 5, to my sequence first term, which is 1? How do I get from 5 to 1? Well, clearly, I take away 4. And if 56 is in the sequence, this will solve and I can find n to give me a whole number. If n is a decimal, then it's not in the sequence. Okay, so if I can solve this using algebra and it gives me a whole number, then I do know that 56 is in the sequence. Now, you could obviously keep going with your sequences, but because you are able mathematicians, I'm extending your learning here. So We know that I need to get rid of that first, the inverse of minusing 4. Well, 5 lots of the number then is equal to 56 add 4. And we have done this before in class. You'll remember doing this. The inverse of taking away is adding. So 5 lots of a number is equal to 56 add 4, which is 60. Remember, we used to put our square bracket underneath and make it a bit simplify it slightly. So 5 lots of a number is equal to 60. So the number on its own then, the term it's going to be would be the same as, remember there's a times sign between this. This means 5 lots of a number, 5 times n, 5 times the number. So 5 lots of that number, the inverse of this times sign is divide, would be 60 divided by, not 12, divided by 5, which is 12. Now, because n is equal to 12 then, it's given me a whole number, so I know that 56 is in the sequence. So I'm challenging you, and if you manage to solve these like this using algebra, tweet them to me or send them to me in eSchools and I can have a look. It would be lovely to see you solving the equations like this. This is actually called working out the nth term, which you won't do until you go into year 7, but it'd be good to start now. So we do know. And just to prove to you that it's the 12th term of this sequence, if I continue it on, it'd be 21, then obviously it'd be 26, 31, 36, 41, 46, 51, 56. It should be the number 12. So 12th term. So first term, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. And there it is. It's our 12th term. Okay, so when you start doing GCSEs, you could be asked, what's the 5th term of this sequence? What's the 8th term of this sequence? And it involves doing what I've done there, putting the normal times table underneath and then working out what you've subtracted by. Okay, and would 93 be in this sequence? Well, again, let's have a look, and you can see the numbers are getting bigger. So my 6 is 1, and then it's 6, 11, and then it was 16. Then it was 21, and then it was 26. And then we know that our usual is 5, 10, 15, 20, 25, 30. So we know we're subtracting 4. So 5 lots of my number, we're doing the 5 times table, timesing it by the number. We're taking away 4 to get from the first original to my sequence. We're taking away 4. And then we're checking if 93 is in there. So if this gives us a decimal, we know it doesn't work. So inverse of taking away 4 is adding 4. So the first thing to do is add 4 onto 93, which is 97. Okay, 4, 5, 6, 7. And then obviously 5 times by the number is 97. So I need to do the inverse of timesing by the number. So I'm going to do n is equal to 97 divided by 5, which does not give me a whole number. Therefore, 93 is not in that sequence. And we know that because all of these sequences, the original sequence ends in either a 6 or a 1, doesn't it? So 93 is not in there. Okay. So that is some quite high level maths there for you. So if you can tweet me those, send me the workings out you do, solving it like that, I will be really, really impressed. So I'm challenging you, please do it. Now, then you've got this here picture. You'll recognise these SAT style questions. You've got this picture and the number of circles and the number of squares. So circle 1 has 3 squares. Circle 2 then, this is when there's 2 circles. So from this picture here, there are 1, 2, 3, 4, 5, 6 squares. So we've added 3 there. Let's check. Remember, we're doing arithmetic sequences, not geometric, so chances are we're just going to add 3 each time. Let's check. Yeah, I'm adding another 3 on there, so that's going to be 9, and then I'm adding another 3 on there, so that's 12, because remember this is part of that sequence. Okay, so that's the number of squares. So whilst we've now got those right, how many circles will there be in the pattern with 15 squares? Well, how do I get from the number of circles to the number of squares? Well, we times by 3, don't we? So if I'm going from the number of squares, 15 squares, to the number of circles, we're going to go this way. So we would divide it by 3. 15 divided by 3 is obviously 5, and that would be the next one in our sequence. And then, will there ever be a pattern with 32 squares? Well, let's check. This is a bit like what we did on the previous page. Okay, will there ever be one with 32 squares? So we know we're doing our 3 times table, 3, 6, 9, 12, 15, etc. So will the number 32 be in there? Well, is 32 in the 3 times table? So we're doing 3n, aren't we? We're not adding because we're not adding or taking away anything because our pattern actually does do the 3 times table. So there's no plus or minus here. We just need to say 3n is equal to 32. So n would be 32 divided by 3, which is not in the 3 times table. So no, it would not be in there. Okay. Moving on, we've got a question here involving dots and 1 row, 2 row, etc. So let's just check. The sequence here clearly goes, if I do it in blue to stick with the dots, we've got 1, then we've got 5, then we've got 9, and then we've got 4, 8, 12, 13, and then we've got 4, 8, 12, 16, 17, 4, 8, 12, 16, 20, 21. So that's our sequence, isn't it? We've got pictures, but the actual sequence is 1, 5, 9, 13, 17, 21. Okay, and what are we adding each time then? Well, we're definitely doing our 4 times table, aren't we? We're adding 4. So underneath the first term would be 4, 8, 12, 16, 20, 24, because that's my normal 4 times table. So we know that it's going to be 4 lots of my number, or the row in this case. However, how do I get from my times table to my actual sequence? Well, I take away 3, don't I? I take away 3. So I'm going to subtract 3 from that. And that is my nth term then. 4 lots of n take away 3. So the question says, how many dots would there be in a pattern with 15 complete rows? Well, in other words, instead of n, we're going to have the number 15. So I'm going to do 4 times by 15 and then take away 3. So 4 times by 15 is 60. Take away 3 would be 57 dots. Okay, there would be 57 dots. And I could check that by writing it out and get all the way to 15, but that would take me quite a long time. And then how many rows of 4 would there be in a pattern with 101 dots? So I would do my nth term, which is 4n minus 3, is equal to 101. The first thing I'm going to do is take away this 3 and add it on. So 4n is equal to 104. I need to half 104, well, and half it again. Half 104 would be 52. Half it again would be 26. So n is equal to 104 divided by 4, which is 26. So how many rows of 4 would there be in a pattern with 101 dots? Well, there would be 26 of them, and I've used the nth term to solve that. Okay. Then you've got some algebra questions, which again, straightforward, not going to insult you by going through them. I'm sure you'll be absolutely fine. Just remember to follow the inverse if you need to. A puzzle, which looks like this, which is fine. Remember to work out the ones you know first. So we know we can work out here the apple because 4 lots of them are 76. So 4 lots of the apples are 76. So 1 apple would be 76 divided by 4. And then I could fill in all the apples and work out the others. And then you've got a question involving some worded problems there for algebra. Okay. So have a good few days. Enjoy the weekend. The next video will be on Monday. I look forward to seeing your scores as they come in. Some of you need to do a little bit of catching up, but I'm sure you will do that. And hopefully we will see you soon.